Good morning, dear all. In this video, we will discuss the new topic of Unit B, that is nuclear energy. So, if I say nuclear energy, what does it mean? It means the energy which is liberated during the radioactivity process. We know that in radioactivity process, we have a radioactive element which is when reacted or when bombarded with fast moving neutrons, it split out into its daughter nuclei, and along with the daughter product it also releases large amount of heat and energy. So the energy which is liberated as a product in the process of radioactivity is only known as nuclear energy. So we know that nuclear energy is also or we can say that nuclear reaction is also a form of a chemical reaction. Like, it is not similar to chemical reaction, but it also carries a form of reaction with it. Like, we have a radioactive element which when reacts with the neutron give rise to a new product. Therefore there is a equation or there is a reaction. So same, the conservation of energy or the conservation of mass is also valid in nuclear reaction as well. That means in nuclear reaction, when radioactive element is split out into the heat, energy and daughter product, it also holds the conservation of mass, which says that the total mass of the reactant must be equals to total mass of the product. But according to Einstein, it was found that when we have calculated the mass of the product, we found that the mass of the product was somehow less than the mass of the reactant. That means there is a difference in the mass of reactant and product. So he said that the difference in the mass of the product is because that some of the energy is lost during the reaction, and that energy is related in terms of the mass by Einstein energy mass relation, that is E is equals to mc square. He said कि जो भी मास में लॉस हो रहा है वो किस फॉर्म में इन्वॉल्वमेंट में रिलीज हो रहा है, एनर्जी के फॉर्म में, and therefore he formed the equation E is equals to mc square, and this equation is only known as energy mass relation, where E is the energy liberated in the atmosphere, m is the mass, and C there we have seen, see this type of triangle delta m. Delta represents the change in the mass, so delta m represents the change in the mass, and C is the speed of light, which is equals to 3 into 10 to the power 8 meter per second. So E is the reaction energy liberated, and thus since this energy is liberated during the nuclear reaction, and hence it is known as nuclear energy. Now it is said that when 1 kg of mass is lost, that means when delta m becomes 1 kg, and we know that C is equals to 3 into 10 to the power 8, then we have calculated the value and we found that when 1 kg of mass is lost, and then the value of E is equals to 9 into 10 to the power 16 joule, or it is equals to 2.5 into 10 to the power 10 kilowatt hour of energy. That means when delta m becomes 1 kg and C becomes 3 into 10 to the power 8 meter per second square, then the value of E is this and this in terms of kilowatt hour. The next is when the mass is considered in terms of atomic mass unit. That means let us consider that the change in the mass is equals to 1 atomic mass unit, that is 1 AMU. Then what will be the amount of energy liberated? Putting the value of C is equals to 3 into 10 to the power 8. Overall, finally we found that E liberated in case of atomic mass unit is 931 millielectron volt. So this is all about nuclear energy, and this is all about we are having in the syllabus. Hope this is clear to you. Kindly finish all the notes so that in our next class we can start with our new chapter. Thank you.